So a rational number, you might remember, is a number that you can write as a fraction. So I might give you something like 9 to the 1/2. I did. I wrote it on 9 to the 1/2. Well, I'm not sure what 9 to the 1/2 is, but what would happen if I were to square that? It would become 9 because when we have a power and another power, one of our rules the other day said, what do you do when you have a power and another power? Multiply them. 1/2 times 2 is 1. So this is 9. I also happen to know that if I take 3 and I square it, 3 squared gives me 9.
So the answer is 3.
So it makes sense that 9 to the 1/2 should be the number 3. So how are 9 and 3 related? 3 is the square root of 9. So 9 to the 1/2 is the square root of 9, which is 3. So if I gave you 8 to the 1/3, absolutely, that would be cube root of 8, which is 2. So fractional powers make roots. So remember the other day we had a long list of rules about exponents?
7 to be exact.
7 to be exact. We're going to add 2 more rules, 8 and 9. 8 and 9. So rule number 1 is, if I have a base and I raise it to a fractional power, that's the same as doing the root. Because the other day we had a list of 7 rules for exponents, and I'm adding 2 more rules. So that's rule number 8 for our long list. Unfortunately, I didn't keep the sheet of paper that had the list, so I can't just add it. That's going to be it. And the last rule is, if I have a base and it has a fractional power, but the top is not the number 1, what that means to do is the bottom number is the root, the top number is the exponent. So when we have fractional powers, the bottom number always becomes the root, the top number always becomes the exponent.
And the bottom number would be 0.
Can the bottom number be 0? No. N cannot be 0. I clearly cannot divide by 0, so n can't be 0 for either of those. All right, so some examples. Let's say I gave you 4 to the 3/2. 4 to the 3/2. The 2 on bottom tells you I'm asking you to take the square root of 4, and then the 3 on top tells you I want you to cube that. Square root of 4 is? Well, square root of 4 is 2. And then 2 cubed is 8. All right, how about 9 to the negative 1/2?
Oh no, you can't.
Oh, I did.
It's the square root of 9, which is 3, negative 1, so it's 1.
Correct. The negative does just like it did last time. The negative is nothing new. The negative dumps that thing down to the bottom. So we get rid of the negative by dumping it down to the bottom. And then the 9 to the 1/2, that's just a different way of writing square root of 9. So the final answer is 1/3. So we use those same rules we had last time. Negatives just drop things to the bottom. All right, how about 27 to the negative 4/3. All right, so the 3 on bottom tells you that's a cube root. So you do cube root of 27, and then you're going to have a negative 4 power on that. Cube root of 27 happens to be a nice number. It's 3, so this is 3 to the negative 4. which is 1 over 3 to the 4th. The negative just drops that to the bottom. 3 to the 4th happens to be 81. So my final answer is 1 over 81. Questions on that?
Yes.
Oh, yeah. It's really stupid with fractions?
Negative 777 over 85.
So you mean if I were to give you something like x to the 1/2 times x to the 2/3?
X to the 6, 7.
Now we'll start with that one. X to the 1/2 times x to the 2/3. What do you have to do? Find a pillow and cry. That's not what you have to do. That's what you should do. No.
Yes.
What do you do when you're multiplying things?
You add the X.
You add the exponents. So yeah, it's going to get silly with fractions. You could add those fractions together. The common denominator would be 6. So that would be 3/6 plus 4/6. So your final answer would be x to the 7/6. He did say 7/6. I heard. All right. How about
So you want to bring x to 7, 6,
typically the rule is if your problem starts with exponents, your problem ends with exponents. On the other hand, if I gave you square root of x times cube root of x, it starts with roots, so we'll leave our final answer with roots. That's kind of a general rule. But in order to do this, what you have to do is you have to convert it to powers. You write it as x to the 1/2 times x to the 1/3. Common denominator is 6 again, and you can just check my work here. You get x to the 5/6. Oops. So typically we would write that as 6th root of x to the 5th. Since we started with roots, we would end with roots. This was a mistake. Ignore that. 5 over 6. That was a typo. Hey, it's raining. All right, what if I gave you 77 x to the 5/12 y to the 2/3 divided by 11. No, I went with 11. X to the minus 1/3 y to the 5/6. What's that? No comment. All right, well, I'll do the hard part. 77 divided by 11, that's 7.
Great.
Great. Yes.
That's excellent.
What's next?
Then we have complex fractions, so let's focus on the top. So,
Well, we don't really have a complex fraction because these are exponents.
I mean, you still gotta do some math.
I'm still going to do some math. I don't disagree with that. What kind of math would I do?
Exponent math.
Exponent math. So what am I going to do with the x's?
Stuff.
When you have one on top and one on bottom, what do you do with the powers? You subtract them. So while fractions are a pain in the neck, of course we have calculators. There's nothing preventing me from doing 5/12 minus negative 1/3 x to the 3/4. So while these fractions can be a pain in the neck, you're allowed to use your calculator to deal with them. I don't expect you to add, subtract, multiply, and divide a bunch of fractions by hand. Use your calculator. And then how about the y's? 2/3 minus 5/6. Calculator says negative 1/6. Since the answer turned out to be negative, what's going to happen to it? It would go... Well, I had one on top and one on bottom.
Well, the top one gets crossed over.
All right, so let me ask you a question.
Good.
What number is bigger, 2/3 or 5/6? 5/6 is bigger. Since the bigger one is on bottom, shouldn't the answer go on bottom?
No.
Yeah.
It shouldn't.
It should.
But then you got a -1/6.
I got a -1/6. All right, so what that's telling me is I have y to the -1/6 on top. So what does a negative power do? It goes to the bottom. So my final answer should be 7x to the 3/4 divided by y to the 1/6. Questions on that? Alright, then you're going to have even more fun ones. You might have, let's say we have 8x to the -1/3 y to the 3/5 divided by, nah, I'm done with 77 today.
64. No. 66.
27 x to the 2/5
And then C.
y to the -1/3, and then the whole thing, holy mackerel,
9.
is raised to the -2/3.
Which that is then raised to the 1/3.
No, that's enough power.
To the Google. To the Google.
Do the Google.
To the Google Class.
Yeah.
To the Google.
Where would you begin?
To the Yoda. Well, where do you begin?
I would start inside the parentheses first. I agree with you completely. So first I look at the numbers, 8/27. Can I do anything with 8/27? No, they don't have anything in common. All right, so 8/27, nothing there. Then I would go to the y's. I'm sorry, the x's.
Well, the X is excluded. That first X goes down.
This one, x goes down, okay. So we're going to write it as x to the 2/5, x to the 1/3. That x with a negative power, it goes down to the bottom.
And that Y on bottom goes up.
That y on bottom goes up on top, all right. So that's y to the 3/5, y to the 1/3. And I still have an exponent of -2/3 outside of the whole great big thing. All right, so now I deal with my things here. This is 8/27. My y's, I go ahead and I add my powers. 3/5 plus 1/3. Calculator says 14/15, so that's y to the 14/15. 2/5 plus 1/3 is 11/15. X to the 11/15. Still got a great big power on the outside, great big parentheses there, and a -2/3. All right, I think I would take the -2/3. I think I would do it in steps. What does the negative do? It flips everything. So I think I would start by just flipping things first. I would write 27x to the 11/15 over 8y to the 14/15 to the 2/3. So I would get rid of that minus sign first. And then I think I would do the 2/3. All right. So how much is 27 to the 2/3? 18? No, it's not 18. That's 27 times 2/3. What's 27 raised to the 2/3? What's the 3 on bottom tell you to do?
9.
Root. So what's the cube root of 27? 3, and then the 2 on top tells you to square. 3 squared is 9. So that's a 9. What do you do with the x to the 2/15? I'm sorry, x to the 11/15 to the 2/3. What do you do when you have a power and another power? That's where you multiply. When you have a power followed by another power, you multiply. So that's y to the 22/45. Multiply tops, multiply bottoms. And I don't think anything simplifies there, unfortunately. Over. Same deal on bottom. I take that should be an x. Thank you. Yes, it's an x. Same thing on bottom. I take 8 And I do the cube root. Cube root of 8 is 2, and then the 2 on top tells me to square. The number on bottom is always the root. Cube root of 8 is 2. The number on top is always the exponent. 2 squared is 4. And then same deal. I have a power and another power. I multiply them. That's going to be 28 over 45. So, lots of work with fractions, but most of the work with fractions isn't that hard, especially when you use your calculator. And I highly encourage you to use your calculator here. Use your calculator to add and subtract and multiply and divide all those fractions. I don't expect you to do it by hand. You can if you want to. It won't bother me if you do it by hand. But I think it would be quicker and more accurate if you were to do it using your calculator.
Would we get bonus points?
You would not get bonus points for doing it by hand. That's like, my daughter's in 5th grade and she's learned how to add fractions, so I don't give you bonus points for doing 5th grade stuff. I know a lot of people don't know 5th grade math, trust me. I teach math every day, I know.
I know. Just people.